About the doubts. CAE 4. Okay. Question number 8. Okay. For HNO3 gives 4NO2 plus 2H2O plus O2. It has started with pure HNO3. Okay. It has started with pure HNO3. It is important at a point. Okay. Next, P is the total pressure at equilibrium. Okay. So we'll start. So when there is a pure HNO3, so that means let's this be P naught, pure HNO3 initial. At that point of time, the amount of NO2 or the partial pressure of NO2 will be 0, water will be 0 and oxygen will be 0. Okay. So here water is given as a gas, so you have to consider the pressures. Everything is a gas. Okay. HNO3 is also given as gas. Final or at equilibrium. So during this time you have to take something as X. So let us take first that the oxygen produced is PO2. Oxygen produced is PO2. If oxygen is produced PO2, then the reacted HNO3 is 4PO2. If the oxygen produced is PO2, then NO2 formed is 4PO2. H2O formed is 2PO2. Okay. These are the partial pressures at equilibrium. Okay. So if we add all this thing, then you will get plus 3 PO2, P naught plus 3 PO2. Now this is equal to given as P. This is given as P. Okay. So from here I can calculate what is P naught minus 4 PO2. If you have to calculate what is P naught minus 4 PO2, so see from here you will get P naught. P naught is equal to P minus 3 PO2. So if you put this over here, you will get in all the 4 options there is 7 PO2. So definitely we are going in the correct direction. So P naught is P minus 3 PO2 minus 4 PO2. That is P minus 7 PO2. So this is nothing but partial pressure of HNO3, this one at equilibrium. So this will be required while we find out the equilibrium constant. Okay, now what is 4 PO2? That also easily we can find out. 4 PO2 is 4 P minus 3 PO2. So there is no requirement of using PO2 because PO2 is already there in the answers. So you can write 4 PO2 directly. So this is not required. Only I want to eliminate the P naught part because in all the 4 options there is no P naught. There is PO2. So PO2 can be kept. So after this what we have to do? We have to find out the equilibrium constant. So what will be Kp? Kp will be 4 PO2 whole to the power 4 2 PO2 whole square into only PO2 divided by this one. So this one is already done as this. So we'll write P minus 7 PO2 whole to the power 4. So here 4 to the power 4 into 2 to the 2 square. PO2 whole to the power 7 divided by P minus 7 PO2 whole to the power 4. So this will correspond to option B, which is the correct answer. Now going to question number 18. AgCN2. Ag plus 2Cn minus. Equilibrium constant of this reaction is given 4 into 10 to the power minus 19. Okay. Silver ion concentration has to be found out. This needs to be found out. Originally 0.1 molar KCN was there and 0.03 molar AgNO3 was there. Okay. So both this compound KCN and AgNO3 are very much ionic compound, whereas this AgCN2 part is not a very good dissociator, that it is not going to dissociate very easily. This will be 1 minus. Okay. So at equilibrium we need to first find out what is the concentration of Cn minus, because Ag plus we have to find out at equilibrium. Cn minus concentration we need to know. We cannot find out both, it will be difficult. We will want to know. So how will we know? Because we already know that this KCN and AgNO3 is going to react and form AgCN2 minus. Okay. So first we have to write the reaction. Reaction is written, but the formation reaction of AgCN2 KNO3 plus KCN KCN plus AgNO3. In this reaction, first the formation is AgCN2 plus K plus KNO3. Sorry, K plus NO3 minus actually. That's it. Because KNO3 is an ionic compound. It is going to break completely, so there won't be any KNO3 left. Okay. So first it is 0.1 molar and this is 0.03 molar. This is 0, this is 0, this is 0. Next, what happens next? Next, this 0.1 molar gets dissociated. So we will take that all this AgNO3 reacts with KCN. So this AgNO3 is the limiting reactant. So here what will be left? 0.1 minus 0.03. This will be left. This will be 0. Formation 0.03. This one, everything will be 0.03. Now one thing is, I have not balanced this reaction. We should have balanced it. This will be 2 KCN. Okay? Yeah. So if it is 2 KCN, then it is balanced, but here you have to do 2K plus, then only it is balanced. So this will be 0.06 and this also will be 0.06. This part is a little bit trickier. 0.03 molar of AgNO3 was there. So reaction of 1 mole AgNO3 happens with 2 mole KCN. So when 0.03 moles of AgNO3 reacts and becomes 0, we are required to react 0.06 moles of KCN. So 0.06 moles is going to get subtracted. So remaining moles of KCN is 0.04 and others are like this. Okay? So this will be 2K plus. Okay? So this is the half part of the problem. Achha. Now after this, AgCN2 breaks. To form Ag plus 2Cn minus. AgCN2 formed was 0.03 moles. So this was 0.03 moles. This is not known. This is 0 at start. After some time, it is going to get changed. But beforehand, one thing has to be remembered, that this Cn minus also comes from KCN. How much KCN is left behind? 0.04 molar KCN is left behind. So initially there will be that 0.04 molar of KCN. So now finally what happens? So finally we don't know how much amount of AgCN2 has dissociated. So we will take that as X. So if this is X moles have dissociated, here the formation will be X. Here it will be 2X plus what was originally 0.04. Okay. So you can clearly understand the concentration of Ag plus is X. So Kc will be equal to Ag plus concentration, Cn minus concentration whole square divided by AgCN2 minus. So this will be X 2X plus 0.04 whole square divided by 0.03 minus X, and the value of Kc is given as 4 into 10 to the power minus 19. So 4 into 10 to the power minus 19 is equal to 0.03 Now you can solve this and complete. So during solving this one, you can easily take this x as 0, because x is very small with respect to 0.3, 0.03 and 0.04. So this will help you in finding out x easily. So only if the dissociation is very small, we can take this assumption. X is equal to 1, 4 will be cancelled out. 9 into 10 to the power minus 19 divided by 4. So this will be 2.25 into 10 to the power minus 19.
নিচের পার্টেরটাতে তো অ্যাকচুয়ালি স্কয়ার নেই 0.03 মাইনাস x যেটা আছে
Oh, acha, acha. Then you can just leave this one. Sorry. So this will be 3 by 4. So this will be 0.75. Sorry, 0.75. Correct. If you add all this, this will be equal to 960. Things are very easy now. 600 plus 900x is equal to 960. You can calculate, this will come around 900. 900x. So 900x is equal to 600 going this side, 360. So x is equal to 360 by 900, 50, 6. So you have to find out what is coming in fraction. 6 by 15. 0.4. Okay. So this will be the answer. So let us first understand what is number 10. Number 10, a equation is given, N2O4 reversible 2NO2. Okay. This total equilibrium setup is at temperature is equal to 1000 Kelvin. Total equilibrium setup. Pressure is 1 bar. Total volume is 5 liter. Okay. What is asked? At equilibrium, NO2 is right. At equilibrium, NO2 is 50% of volume. So we have to find out Kc. Very good, no problem. So one by one, let us understand this one. So let us first see initially. Initially, this is 1 and this is 0. Let us take like this. At equilibrium, we have considered 1 mole over here. Okay. At equilibrium, that is final, 1 minus x, and here it is 2x. Moles, only moles. We are talking about moles because we have to find out Kc. We are not concerned about Kp. We have to find out Kc. So 1 minus x, 2x. Now what is total moles? You just add this, you will get 1 plus x. This is the total moles. So see, we know very well that moles is directly proportional to volume. This very well. So here, when there was 1 mole, and that has corresponded to V volume, then 1 plus x mole will correspond to V 1 plus x mole. Okay. Now, what is the volume of NO2? That we have to find out right now. So, if I want to find out the volume of NO2, then 2x will correspond to basically 2 into V, has to be 2 into V. So, this is the volume of total mixture and this is the volume of NO2. So, 2V by V1 plus x, 2V by V1 plus x is equal to 50%, means 50 by 100, VV cancels out. So, from here you will be able to find out what is x, right. So, please calculate what is x. So, here it is 2, 2, 4, 1 plus x is equal to 4, 1 by 1 plus x. Just calculate and let me know what is x. How much it is coming?
3.
X is coming is equal to 3. So, here our mistake is 2Vx. 2x will correspond to 2Vx, not 2V. So, then x will come out to be 1 by 3. It will come 1 by 3. You can check, this will come. So, once we get x is 1 by 3, I can find out the number of moles of N2O4 and NO2. So, N2O4 is 2 by 3 and NO2 is 2 into 1 by 3, that is 2 by 3. Oh, very good. Has to be, because this is 50% of the total. Okay. So, both are 2 by 3. Now, if you want to calculate Kc, Kc is basically NO2 square by N2O4. So, NO2 is 2 by 3, that is mole, not molarity. I have to use molarity. So, I have to divide by 5 liter. So, 2 by 3 into 5, that is 2 by 15 whole square. Here also 2 by 3 into 5. So, one part cancels out. So, this becomes 2 by 15. Okay. So, whatever is the answer, 2 by 15 will come out to be something like 0.1 something. So, what is the option given over here? 0.133. That will be the answer.
Sir, आगे page पर जाओ.
So, first of all, let us see what is the question. Hydrochloric acid is added to cobalt 2 nitrate solution. The following reaction takes place. Okay. Okay, this is given as pink. The solution is blue at room temperature, however, it turns pink when cooled in freezing mixture. Based upon this, which of the following expression is correct for the forward reaction? Okay, very good. The solution is blue when it is at room temperature. So, this is going to this side when temperature increases. It is going to this side when temperature decreases. So that means if I increase temperature, the solution is going to be this one. That means forward reaction will happen if I increase temperature. So definitely that means forward reaction happens with addition of heat. So this is an endothermic reaction. This is a endothermic reaction in case of forward reaction. So endothermic reaction means del H will be more than 0. Endothermic reaction means del H will be more than 0. So I hope this is clear. Question is, AgCl is a sparingly soluble salt. AgCl is a sparingly soluble salt. So when AgCl dissociates, it becomes Ag plus Cl minus. But generally it does not dissociate, but even if it dissociates, this will be the dissociation reaction. So let us first understand the reaction and the implications of it. So when AgCl is going to break down into Ag plus Cl minus, that is the forward reaction, then it is called solubilization. Mane AgCl is getting solubilized into water. Whatever is getting, whatever, maybe out of 100 moles, maybe 0.1 moles is getting solubilized, but getting. And when the backward reaction is concerned, then Ag plus and Cl minus is combining to from AgCl. Ag plus and Cl minus is combining to form AgCl. So that is the backward reaction. So the forward reaction if the forward reaction increases, then solubility will increase. So this is the meaning of this reaction. Now what is asked? The first, it is asked, if NH3 is added, will there be increase in solubility? Now this question is not of physical chemistry directly. This question is a class 10th stuff. AgCl is soluble in ammonia. Okay. So the first is correct, that yes, the forward reaction will increase, the solubility will increase if NH3 is added. AgCl is soluble in ammonia. So when you add NH3, if you add NH3 in it, then what happens? Ag complexes with ammonia. Ag complexes with ammonia when you add NH3 to it. So it becomes soluble. It becomes soluble in water. Next, there will be increase in solubility if NaCl or AgNO3 is added. If you add NaCl, suppose I am adding NaCl. So NaCl will give Cl minus in the reaction mixture. That means products will increase, and if product increases, backward reaction increases. But backward reaction is not solubility, forward reaction is solubility. So if you add NaCl, there will be no increase in solubility. So option B is wrong. Decrease in solubility if KCl is added. Yes. So just you replace NaCl with KCl. When you add KCl, KCl also gives Cl minus. So that Cl minus concentration is going to increase. That means the product concentration is going to increase. So if there is product concentration increase, backward reaction will increase, then solubility will decrease. So that is true. So option C is correct. Option D, it is given as decrease in solubility if water is added. Decrease in solubility if water is added. Whenever you add more and more solvent, solubility will never decrease. It can increase, it will never decrease. So it is also wrong option. So here the correct options are A and C. দেখো বুঝতে পেরেছো, কোনো ডাউট থাকলে বলো।
হ্যাঁ স্যার ঠিক আছে। আনসারে এ আর ডি দেওয়া আছে।
এ আর ডি দেওয়া আছে, না এ আর ডি হবে না, এ আর সি হবে, ঠিক আছে, এ আর ডি হবে না। ডিক্রিজ ইন সলিবিলিটি তো বলেছে কেসিএল, হ্যাঁ ঠিকই তো আছে, কেসিএল অ্যাড করলে তো ডিক্রিজই হবে সলিবিলিটি, ঠিক আছে, ডি হবে না। অ্যাডিশন অফ ওয়াটার হলে ইনক্রিজ হতে পারে, ডিক্রিজ হবে না, ঠিক আছে, এটা কারেক্ট, কোনো প্রবলেম নেই। ওকে, নেক্সট কোশ্চেন কোনটাতে যাবো আমরা? কোশ্চেন নাম্বার 9। ও গ্রাফ, গ্রাফের কোশ্চেন খুব ইম্পর্টেন্ট, গ্রাফের কোশ্চেন থেকে কোশ্চেন আসে যেইতে। হ্যাবার্স প্রসেস, একটু দেখি দা, 500 ডিগ্রি 400 ডিগ্রি, ও ইট ইজ অ্যান এক্সোথার্মিক প্রসেস, টেম্পারেচার বাড়িয়ে লাভ নেই। প্রেশার বাড়াতে হবে। Okay. 9. Question number 9. Haber's process. N2 plus 3H2 gives 2NH3 plus heat, ठीक है। Now see, if this process happens with decrease in volume, this process happens with decrease in volume. So if you increase pressure, forward reaction will increase. So the graph with pressure and percentage NH3 yield generally will be increasing. As you increase the pressure, percentage will increase. So here there are two graphs given like this. So graph will be of this kind, that is for sure. It is not going to decrease, it is going to increase. Next is, this is a exothermic reaction. So increase in temperature will decrease the forward reaction. So when there is 500 degrees Celsius, the yield will be lesser. When there is 400 degrees Celsius, the yield will be more. That's it. Question number 9. Option A is the correct option. Question number 10. 2SO2 plus O2 2SO3 plus heat. This is again exothermic reaction. So increase in temperature is not going to help. So we have to find out how we can increase the forward reaction. So if you increase the temperature, forward reaction is not going to increase, that is for sure. If you increase the pressure, forward reaction is going to increase. One option is given as volume of the reaction flask is decreased. So if volume decreases, definitely pressure will increase. Not only pressure, the concentration is also going to increase. Both the cases will help in conversion towards SO3 because it happens with decrease in volume. So higher pressure will help. So option D is correct over here. O2 is removed from the mixture. O2 is reactant. If you remove reactant from the mixture, product is never going to get formed. So it is not possible. টেম্পারেচার ইনক্রিজ তো হবে না। নেক্সট, inert gas is added to the mixture. Inert gas addition. Yes, if you add inert gas into the mixture, then what happens? The partial pressures gets increased. So as you increase the pressure in this system, there is chances that the conversion will increase, because as you increase the pressure, this reaction happens better with the increase in pressure in case of forward process. So yes, option B can also be correct. Okay. Ice and water happens to be at equilibrium. When placed in a closed container with 1 atmosphere pressure at 273 Kelvin. The pressure of the system is increased to 2 atmosphere. Okay. Now, pressure goes to 2 atmosphere. So, whenever pressure is increased, the freezing point decreases. Okay. Whenever pressure is increased, the freezing point of water decreases. So, as the freezing point of water is decreasing, previously at 1 atmosphere, when you are maintaining 273 Kelvin, ice and water remains in equilibrium. But whenever freezing point is decreasing, that means the freezing point at this moment is 271. Freezing point, let's take it as 271. But the temperature that you have is 273 Kelvin. So definitely at this temperature, the ice is going to get converted to water. So yes, with time, ice is going to completely change to water. That is the observation.